again and again. You can see. So what exactly we had to take away from the gradient descent is we need to analyze the weights are going to be updating. We eventually calculate the loss up to the global minima to convergence your cost function. So that is a takeaway from the gradient descent. Once you learn these kind of the plots, you will eventually learn the gradient descent, how that is going to be very helpful. So I will simply write the equation with respect to the gradient descent. That is very slightly easier to understand what are the different weights to update the formula. So suppose I need to update the weights corresponding to W nu. So what will happen? You have to extract, or you have to differentiate with corresponding to the old weights with your derivative function dl by dw with the previous timestamp or previous weights, right? This is the current timestamp, this is the t-1 timestamp, and this is the t-1 timestamp. You have to get the weights corresponding to the each and every node we are going to be get in the hidden layer. So yeah, we already learned these mechanisms in the first lessons of the deep learning, so that you eventually understood this idea what I'm saying with respect to the time axis. So what will happen eventually by using this optimization algorithm, or by using this optimization mathematical equation, we can somehow reduce our loss. So one good mechanism, this is the one advantage I can say. This is the one advantage, but the TK I can say the disadvantage also. It will takes a lot of the time. So this is the one you can say disadvantage with respect to the gradient descent we had. It will takes maybe a couple of the months to train your data sets. If you have very large data sets, very large data sets, it will takes month to train your data set to try to do gradient descent. This is very computationally efficient, I can say, computationally very expensive in compared to all the other algorithms we are going to be used. So one of the good trick and good hack by using gradient descent to extend further, instead of taking, so in the gradient descent what we are going to do, taking all the points, taking in random points, or all the points you can say, taking in random values or in random values, so that it will take too long time. But eventually what will happen, the good idea is going to be come across something called as stochastic gradient descent. SGD we can also call it as for that matter. Stochastic gradient descent is going to be very helpful in this case. Instead of taking all in random points, we can just taking xi in d. For each and every point we can take and compute the derivatives. But what will happen eventually if you take this computation derivative for each and xi, it will compute for one point, but eventually you have to compute for all the points, right? So you will get the loss for the first point, that is fine, but you will get the for the second point, that is also fine, but you have so many different points in this area also. First is you are taking all the data at a time, but second thing is taking one point at a time. So that is a one you can say the advantage with the stochastic gradient descent, but still it will also take a lot of the time to compute all the points, right? So this is also one disadvantage with respect to the stochastic gradient descents. So every eventual algorithm may not be perfect. First thing first, all the algorithms having their own disadvantages and advantages with respect to whatever we are learning. So this is going to be happen in terms of a decade of experience, and they have already made on top of the gradient descent and also the stochastic gradient descent, so that they come across the new ideas and new innovations with respect to the optimization algorithms. So still in the 2019, 2020, 2021 also, we are currently researching the things with respect to the optimizers to get our good model results. So still it's in the research position. You had to learn so many things once you end up with whatever the basic and foundation skills you are going to be learned for the optimizations. And the third important model is batch size or mini batch mini batch HGD. So what I will do, I will take, instead of all the points, 1 point, second point, third point, I will take only the batch number of the points. Suppose I will take only the 100 points and compute the computation efficiency by using the each and xi. So I will take 100 points. Okay, I will take 100 k points. You can take maybe k points like that. You can compute by using your batch size and by using the stochastic gradient descent algorithm. So if you take the 100 points, it will be takes maybe 2 to 3 hours to compute. 2 to 3 hours to compute. So is this going to be much more efficient? Because we are taking as a only for the gradient descent algorithm on top of it. The idea is same for the stochastic gradient descent and the mini batch SGD. But what will happen? The gradient descent algorithm is much efficient to compute, but it takes a lot of the time. But if you are understood the intuitiveness with respect to the gradient descent and mini batch SGD we are using, whatever the information or whatever the retrieval information, minimization of the loss, which will be equal to gradient descents, no, not completely but partially, is going to be equal to your mini batch SGD. So for that we can update the weights corresponding to that. So we can conclude maybe mini batch HCD is one of the major ideas to do any kind of the optimization algorithm for larger data.